Okay, here we go with Factorial ANOVA Day 2. This time we're actually going to conduct the test. So as a reminder, Factorial ANOVA Day 1, we did kind of an overview of all of the elements to the test and how to read it. And I showed you some data I collected in a 2x2 ANOVA. So that's what we're going to be using today. At the end of last time, I asked that you copy that raw data down and make sure that you have the mean and standard deviation for each of the 4 cells, for both of the rows and both of the columns. Now, Factorial ANOVA is actually, it takes a long time to calculate all the sums of squares. So I'm just going to be providing those to you. You won't have to actually calculate sums of squares for this one. But the having the raw data and the means and standard deviations there will be important to make sense of the things that we're doing. I'm afraid that if you didn't have that with you and weren't familiar with it, some of this would be pretty abstract. So get that ready and then we'll move on. Okay, so we're doing a 2x2 ANOVA. My format variable is the block versus Stroop. My colors, I call it simple versus complex. And when you're doing a test with 2 independent variables, each independent variable gets its own hypothesis test. It's called a main effect. And then on top of that, we'll have a test for the interaction. So we're going to have 3 different hypothesis tests. So in this page, what we'll do is we'll set up those in step 1 and step 2 to get ready for the actual test. Okay. So the very first one is the block versus Stroop. That's the format variable. And you should see that this is just a very basic null and alternative hypothesis. Very straightforward. The colors, I just called it simple and complex. So those are very straightforward. What's important here, and this will come up as we look at degrees of freedom, is notice that this one doesn't make any reference to the colors at all. In the table, that's comparing the left column to the right column, ignoring any difference between colors. And you actually have to kind of train yourself to ignore the fact that there are colors in the study while you're looking at that main effect. And similarly, this ignores the fact that there's a difference between block and Stroop. This has everyone in the simple condition, block and Stroop, averaged together, so it makes no distinction there. Okay. All right, so the interaction hypothesis, hopefully you remember this from last time. This one is saying that we're going to test the two means on the top of the table. The way I set up that table, if you have it in front of you, you should be able to see it. It's block versus Stroop, but only in the top row. That's M1 minus M2. So what that's saying is that the null hypothesis says that the difference between block and Stroop will be the same for the simple color condition as it is for the complex condition. Okay? In other words, don't think of that as a equation, just think of that as saying the difference between block and Stroop on the top row and the difference between block and Stroop on the bottom row. All right, so all null hypotheses is that there's no difference or no change or anything like that. So hopefully you're pretty familiar with those. Okay, since we have 3 different hypothesis tests, we have to come up with a critical value for each one. In this particular case, it's going to be the same value every time, but that's not always the case. That's only true for a 2x2 ANOVA. So let me show you how we'll do this. Critical value of F is determined by the degrees of freedom between your groups and within groups. So I'm going to start over here with the format, block versus Stroop. And remember, between groups is K minus 1. Now, it's important here that you do that thing where you ignore the colors, right? We're only talking about format. Format comes in 2 versions, block versus Stroop, so K is equal to 2. and therefore degrees of freedom will be 1. Within groups, degrees of freedom is capital N minus K. That's just the sum of degrees of freedom for each of the groups. Now this is a little bit weird because here I just said K was 2. There's only block versus Stroop format. But within is actually talking about the entire study. In the entire study, a 2 by 2 will have 4 different groups. That's represented here by 1, 2, 3, and 4. So that is actually going to be all 20 people in my study. I had 20 volunteers minus all 4 conditions. So that gives us 16. All right, so taking those numbers, going to the source table, or not the source table, the F table, find 1 degree of freedom up there, 16 down there, and we get a critical value of 4.49. All right, so I'm going to put that there, put a little box around it. That means I've got that one figured out. Okay, that one's ready for step 3. This test, degrees of freedom between is K minus 1. This time we're talking about between colors. Well, there's only simple or complex, so it's 2 again. That gives us a 1. Degrees of freedom within, it's going to be the same every time. So it's 1 comma 16. Notice that's the same as we had before, so I don't have to go back to the table for that. Just copy it right there. Now, had I had 3 color conditions, that would have been a 2, and that would have given us a critical value. So in a 2 by 3 ANOVA, these things don't add up like that. They don't match up like that. So that's just really something that happens in a 2 by 2. And I want to make sure you're aware that that's a special case. All right, finally, the degrees of freedom between for the interaction is the product of degrees of freedom for format and degrees of freedom for colors. They each had 1 degree of freedom, 1 and 1. So the interaction also has 1 degree of freedom. Same within groups, and therefore it's going to have the same critical value. All right, so that's how we find those. I think this part is pretty straightforward, but it's easy to forget this thing right here where K minus 1 is, K refers to the number of levels of that independent variable, where N minus K here is K for the whole study. So not complicated, but easy to forget that part. Okay, so as I was saying, there's a lot to do here with sums of squares, and I'm going to provide you those values, and we'll just fill in the table with the degrees of freedom that we already looked at and calculate mean squares and F. Okay, so I wanted to start with a blank table so I could tell you what this looks like. If you've done a few practice problems with the one-way ANOVA, you're familiar with the total idea here. That's the within groups, and that's the between groups, same as any other ANOVA. In this case, however, between groups can actually unfold in several ways. That's because we've got 2 variables. And so instead of calculating between groups variance up here in the top row, we're going to be calculating format, colors, and interaction. All of those things together would add up to be between groups, but we're not going to test overall between groups. We're going to test these guys. All right, so I went to a website called Vassar Stats, which I'll show you in another video, and I got the sums of squares for this. And I want to show you how to walk through the table and how to solve this if you're given sums of squares. Okay, so the degrees of freedom, as we saw earlier, are K minus 1 for the format, K minus 1 for colors. The interactions, just the product of those 2 degrees of freedom within groups is N minus K, and the total is N minus 1. You might want to hit pause and jot those down, or come back and get that a little bit later. All right, so if I fill in the table, that's what it looks like. 1 degree of freedom for each of the between. Notice that, and within add up to 19. Okay. Incidentally, all the sums of squares there add up to 186.06 too. So in these columns, everything should add up to a total. All right. The next thing we do is we calculate variance. In analysis of variance, we traditionally write MS, which stands for the mean squared error. So this is the sum of squared divided by degrees of freedom. That's an average with a little adjustment there. And we need that for the same 4 rows here. So it might be good to pause and try to get those numbers yourself and come back. All right, so here are the numbers for our mean squared. The next thing we'll work on is calculating our F values. F is mean squared between groups over mean squared within groups. So that's the variance from group means and the variance from individuals being spread out. Now, it's going to use the same MS within for 3 different tests. Okay, so we're going to do this for format. That'll be 53.14 divided by 2.51. Then we'll do that again for colors. That's 69.94 divided by 2.51. And we'll do that again for the interaction, 22.9 divided by 2.51. All right, so if you're playing along at home, hopefully you got those numbers. So that's step 3. If you take out calculating all those sums of squares, it's actually pretty quick. So we analyze variance 3 different ways. Step 4, we need to make our decision. I went back a couple slides and reminded myself in step 2 that the critical value is 4.26, and in our study it's going to be the same all 3 times. So make that decision. Is F of 21.21 greater than the critical value? I think it is. Check for colors. 27.92 is greater than the critical value. And for the interaction, 9.14. All 3 of our tests wind up being statistically significant. It's important to realize that in analysis of variance, those guys are all independent of each other. You can have no significant results. You can have any combination of 1 or 2 significant results, and they can all be significant. Okay, so just the fact that one's significant doesn't mean the others will be. All right, so those guys are all significant. That is most of the hypothesis test. Before we go, I do want to measure effect size. So I'm just going to make a little bit of room here. The effect size for ANOVA is eta squared, Greek E right there. In Factorial ANOVA, there's a little p down there, and that stands for partial eta squared. I'm going to have to move my picture over here. There we go. So in partial eta squared, what we're doing is instead of taking sums of squares between over sums of squares total, we're looking at sums of squares between over that same value plus the error. Okay. So I'm going to come here to format. Format is 53.14. That goes in the numerator. 53.14 plus 40.08 is the denominator. Okay. So that's how we do that. We'll do that for each row. So for colors, 69.94 divided by 69.94 plus 40.08. And finally for this one, 22.9 divided by 22.9 plus 40.08. So those are the values that I got. And those are all pretty good values. Remember that 0.25 is actually pretty big for eta squared. So we have really big effects in all cases. All right, so I just want to close then by showing you a write-up here. I've got 4 different colors here, so you can see that I am actually talking about, in the first sentence, the study that I'm doing. And then the next 3 sentences, each one of them describes in writing, using APA style, what I found. And so when you're reading your article or writing your non-SPSS assignment, there's a model for you. All right, so to conclude, that is how you get through a Factorial ANOVA. I think the tricky parts are finding the degrees of freedom, as I was saying earlier, and also remembering that you're using 3 different tests with 3 different between groups sums of squares, but only one within group. So hopefully that's not too much. So the other things we have to work on in Factorial ANOVA will be thinking about graphing, and I'm running out of time, so I'll just do that in a separate video.